Now, Zener diode is a uh, listen students, now actually since I have come to the PPT mode, if anything, if you message in the chat box, I will not be able to read that. So please, the class CR has to unmute and tell me if any problem is there, okay, regarding the voice or regarding the PPT uh, visibility or anything. Okay, class CR has to unmute and you have to tell me, otherwise I will not come to know, I will be continuing. Okay, fine. Now, coming to Zener diode, actually, what is Zener diode? It is a PN junction diode, but it is highly doped. Okay, it is a PN junction diode which is highly doped. Uh, Actually, normal diodes work in the forward biased condition, okay, and it doesn't work in the reverse bias condition. Whereas the Zener diode has got sharp cutoffs, okay, in the reverse bias region. Okay, in the reverse bias condition, it works more accurately compared to the forward bias condition. This happens due to the doping type. Okay, doping type of the Zener diode. Okay, now, yeah, aim of this experiment is to conduct an experiment to analyze characteristics of Zener diode and design a simple Zener voltage regulator. Okay, and also to determine the line and load regulations. Let me tell you, okay, what is line regulation and what is load regulation and why they are important to us. Okay, now line regulation means you're like see, for each circuit, for each voltage value, we will be having a range. So how the Zener diode will work within that range? Okay, input voltage range, that is line regulation. Okay, in more detail we will be studying when we do the experiment, then that is in a few moments. Then load regulation is how much load can be varied. Okay, so that also we will be studying. Then what are the applications of this Zener diode? Okay, it normally used as a voltage reference. Okay, Zener diodes are used in voltage stabilizers or shunt regulators. Okay, this actually last class we have studied. Zener diodes are used in switching operations. Okay, because of its sharp cutoff points. Zener diodes are used in clipping and clamping circuits. Zener diodes are used in various protection circuits. Okay, fine. Now, coming to the forward and reverse characteristics. Now, when forward bias voltage is applied to the Zener diode, it works like a normal diode. Okay, so you can see the uh, characteristic here. It is like any other normal diode. Okay, as the voltage increases, current increases at around 0.7 volt, it shoots up. Okay, so this is the forward biased characteristic. Okay, when the reverse bias voltage is applied, initially it allows only a small amount of leakage current. Okay, until the reverse breakdown voltage occurs. Okay, this story and all is similar to your normal or any other diode. Okay, so the very small amount of current will be flowing, but at the point of that nearing the breakdown, that is a Zener voltage, okay, suddenly it allows a large amount of current to flow through the device. At this point, it allows a large amount of current to flow through the device. So, okay, sudden rise in the electric current. So, Zener breakdown occurs. Okay, this breakdown voltage of the Zener diode is depends on the your doping. Okay, what type of doping you have done depends on that this voltage. Now if you see the graph here, okay, the current is very small. Okay, then suddenly the current increases. This is in the reverse direction, so it comes negative, but current suddenly shoots up. After that, actually voltage has to remain constant at this point only. Okay, that is the breakdown voltage, but practically a slight variation will be there in the voltage. Okay, that is permissible, but it is almost constant. Okay, fine. So this was about the characteristics. So in this way, if you work, if you little bit vary the doping, then maybe from 1 volt to 200 volt regulators we can design. Okay, from 1 volt to 200 volt we can design. Okay, why actually it is regulating? You see the diagram, graph here, you will get to know the voltage is almost constant here. Okay, voltage is constant, so like whenever we want, wherever we want constant voltage, we go for this. Yeah, coming to the forward characteristics, see this diagram. Okay, a voltage power supply, then 120 ohm resistance. Okay, an ammeter to measure the current. Okay, this is now my Zener diode. I need to find the voltage across the Zener diode. So connect a voltmeter across the Zener diode. Okay, I need to find the current through the diode. So I'm connecting an ammeter in series with the diode. I need to find the voltage across the diode. So I'm connecting the voltmeter parallel to the diode. Okay. Now actually how to design this Zener diode? Okay, that is the forward or see, actually we are designing it for 4.7. Yeah, 4.7 volts. If you see here, let me show you specification, we'll get to know. We want a Zener diode of 4.7 volt, 500 milliwatt. Actually, how did we get this? Okay, 4 millivolt. So, given VL is equal to 4.7, take IL is equal to 10 milliamps. Okay, you know where is IL? Take IL is equal to 10 milliamps. Then find out RL. Okay, find out RL of this. That is the load current, not this. Okay, load current. That you will be getting it as VL by I is equal to 470 ohm. So choose RL is equal to 470. Okay, one second. Just a minute. Okay, fine, fine. Here, say, okay, let me continue this. Design part we will do later. That is for the line regulation. Now coming to the forward characteristics. Okay, now here what we have to do, increase the voltage. Okay, increase the voltage in terms of how much is our voltage, 0.7 volt. So in terms of 0.1, 0.2, note down the voltage and the current. Okay, 0.2, again these two you note down, 0.3, 0.4, 0.5, 0.6. Then when it comes to 0.7, suddenly there is an increment in the current as well as in the voltage. Okay, so this is now my forward characteristics. Coming, that is very simple. Okay, is very similar to my diode characteristics. Now, rest of the circuit will remain same. Only you change this Zener diode, that is reverse this Zener diode, reverse the connection of this Zener diode, then it becomes reverse biased. Okay, it becomes reverse bias characteristics. So in that case, how much is our reverse bias breakdown voltage? It is 5.6 volt. Okay, around 5.6 volt. So how much should I keep? Should I start from 0.1, 0.2? Not necessarily. Okay, because mine is 5.6. So I keep 1 volt. Check these two readings. 2 volt, Check these two readings. 3, 4, 5. Yeah, now actually 5.6 is our theoretically known value. So what we do is after 5, in a smaller interval, we will take the readings. Here we will keep 5.2, take the reading. 5.4, take the reading. Okay, you can make out now only the current would have started shooting up. Okay, I have done the video and I have already posted, okay, in the canvas. After this class, please go through that video. You will understand it clearly. Today only you need to go through, okay, so that you the as you are listening to uh, the theory, okay, explanation, you can relate it easily. So once you keep here 5.6, you observe that the current and the voltage already would have shooted up. Then 5.8, yeah, you take down the 5.86, 7, 8, yeah, stop. Okay, because after that we know that it is going to remain constant, and it will be constant. Though it is in milliamps, it is almost will be constant. Okay, you can see the experiment in the video how we have done. So those two, and then plot the graph. So these two are the forward and reverse characteristics of the Zener diode. Okay. Next, okay, coming to the line regulation. Okay, so in detail, let us study what is line regulation. So this is a type of regulation, okay, where load resistance is fixed, only input voltage is changing. Okay, output voltage remains the same as long as the input voltage is maintained within the regulation range. Now, first let us start. Okay, why this Zener diode is used? Zener diode is used more for the, yeah, anybody has any doubt? Okay, Zener diode is used more for the regulator purpose. So regulation means what? Okay, keeping it within a certain range. Keeping it within the certain range. Now actually we are now see, this is the circuit. Okay, this is the circuit for the line regulation. Now my question is, I am using this is 4.7 volt Zener diode. I am using that Zener diode as a regulator, but I can't assure you that my input voltage will be always constant. Okay, it may vary sometimes. Due to many reasons, it may vary. Now, my doubt is how much I can vary. Okay, when I will get the problem for the equipments. See, now Zener diode is a regulator. How we use our TV stabilizer, all those things. No, that one. Here is my actual equipment. Okay, it may be my washing machine, TV, or anything like this. Okay, laptop, anything. So now I should not allow the way fluctuation in this current to enter to my device. So only I am using this Zener diode so that it regulates. Now my doubt is how much variation can happen here. Okay, so let us take minimum 6 volts to 12 volt. This is the permissible range actually. This is the permissible range. Okay, so theoretically we tell you that within this range you can change. This tends to give the constant output. So let us check whether it happens or no. Okay, so but we should see, otherwise also outside this range also what is going to happen. So initially once you do this circuit, okay, do this circuit, then keep here 2 volts, find the reading. 4 volt, find the reading. 6 volt, take the reading. 7, 8, 9, 10, 11, 12. Okay, you should observe that here it is almost constant. If at all changes are there, it will be in the microampere. Yeah, anybody?
Ma'am,
Yeah.
Vignesh Bhai is unable to join the class.
Actually, I have you know what? Actually, in the Google Meet, the this thing is there. Streaming I have done because it allows only 100 people. So I think he is unable to join. One second.
Yeah, ma'am.
Uh, I don't think so. He can join now because that even that streaming has stopped. Actually, already, yeah, 100 are over. He's only one person left out. Is he the only?
Yes, ma'am.
Okay,
Yes,
fine.
ma'am. Yes.
Okay, okay. Ask him to see the video. Okay, later. I will give the attendance for him. Vignesh Pai, right?
Yes, ma'am.
Okay, okay. Ask him to see my video later. I will post it in the canvas. Okay,
Okay, ma'am.
fine, fine. Mm, 1 second. Uh-huh. Can I? I'll just check whether. Just ask him whether he can join. 1 second. Now, uh, are you able to see the PPT now? Anybody answer no? Orally?
Yes, ma'am.
Yes, ma'am.
Yeah, yeah. I think Vignesh can join now. Uh, okay, you're able to see the PPT, right? Somebody answer.
Yes,
Yes,
ma'am.
ma'am.
Okay, fine. Now, we were talking about the line regulation. Now, actually, we need to see, this is the permissible level. What happens if other, like outside this value range is given? So, try giving 2, 4, 6. Then you give till 12, then 14, 16, like only so much is sufficient. You observe that, okay, here the current variation is really, okay, fluctuating for the outside range, whereas it is varying. I don't say that it remains very constant, because but whatever varying is also in the microamp level. Okay, current varies here in the microamp level within this range. So I can tell you that yes, this is line regulated. Okay, this circuit is line regulated. This is regulating this source. This diode is regulating this source. Okay, now how actually, you can wonder why she has taken 470 ohms, why she has taken 120 ohms here. Okay, so let us see the design. So we were supposed to we were asked to design where VL, that is a regulated voltage, should be 4.7 volt. So take IL is equal to 10 milliamp. Then we get RL is equal to VL by IL, that is equal to 470 ohms. So 470 ohm standard resistance is there. So we take 470 ohms. Total I is equal to, okay, IL plus IZ. Okay, IL plus IZ. So, VI minimum is how much? 6 volt. VI minimum 6 volt should be equal to V naught plus drop across the resistance. V naught, okay, plus drop across the resistance. So, when we do that, V naught, okay, so I minimum is equal to IZ minimum plus IL. I minimum is equal to IZ. That is the, see, where is the fluctuation? Only here could be the fluctuation. Sometimes minimum current flows, sometimes maximum current flows. Okay, so that is IZ minimum plus IL. So I let IZ minimum is equal to 1 if you take, then I get I minimum is equal to 11. Okay, substitute here I minimum and get V minimum. Okay, V minimum is 6 volts. Substitute that and you get RS is equal to 118 ohm. Okay, for which the standard value is 120 ohm. Okay, those who have not understood this, it is very simple circuit theory. Okay, you can later, I have shared the manual. In that the steps are there. Okay, sit and go through it. You need not see the video also just for this. Okay, see the manual, you will be getting it. It's very simple. Similarly, I should find the Vmax. I mean, Vmax is there. Vmax is 12 volts because I've told you the range as 6 to 12 volts. So put Vmax, then find Imax. Okay, same formula. Okay, then you will be getting this Imax. Okay, once Imax is given, then Imax into Vz will give me the watt. Okay, here Imax into Vz will give me the watt of this. Sorry, not this one. Okay. Yeah. So now, where am I? Check here. Power is a 50.83 into 4.7, which gives me 0.239 watt. Okay. So I will be selecting a standard of zero point 0.5 watt. Okay, Zener diode of zero point 0.5 watt, because I need to know, right, when I design what type of Zener diode I require. Okay, I was told that to regulate 4.7 volt, so voltage I took it as 4.7 volt. But what is the power specification? Okay, power specification, when we calculated we got it as 0.239, so zero point 0.5, that is upper limit. That is the power specification for this. So now what are we designing? Our input has to be within 6 to 12 volt. Our input has to be within 6 to 12 volt. Then I can assure you that this Zener diode output will be 4.7 volt throughout. 4.7 volt throughout. Okay, so that was about the line regulation. I varied the input. Still, okay, I got the constant output at the output other side. Next, coming to load regulation. Okay, in this type of regulation, input voltage is fixed. Okay, but load resistance is varying. Okay, output voltage remains same as long as the load resistance is maintained within the regulation range. Okay, now actually what does it mean? I want to regulate this circuit. Okay, so I am using a 4.7 0.5 milliwatt Zener diode. Okay, I am expecting this to be input voltage to be constant. I am expecting load to be constant, so that no much variation in these um, circuit components. I don't want variation also, because these variations will harm my components. Performance of the components will be varied abruptly if the input voltage or current or load resistance, okay, varies. So I don't want that. But okay, practically when we see, it is not possible to keep always the constant load. Okay, load keep little bit, okay, it keeps varying, maybe due to many reasons. Okay, due to many reasons, load impedance keeps varying. So now how can I, in the experiment, how can I change the load? Okay, this is a constant 47 ohm resistor. How can I change? So we connect a pot, see, in series with this. Now what is my load? All this together is my load. Correct, no? Now when I vary this, I am actually varying the complete load. So this is the idea. If you ask me, why have you put pot here? Okay, in the actual circuit, will the pot be there? No, in the actual circuit, pot will not be there. But due to maybe increment in the temperature, okay, or maybe due to high fluctuation, or whatever it is, okay, or maybe the after the continuous usage of the component, okay, this itself changes. 47 ohm itself changes. But in the experiment, I can't show you that, no. Okay, here it is not changing, so I can't show you. So what we have done is we have connected a pot across it, so that it is totally changing. So actually we should see, okay, this is constant. Now we should see now for what extent this voltage difference across this. I am expecting a constant voltage, but if at all difference is there, that is in the permissible range. This can't be too much. This variation can't be too much. Okay, so when we do that, okay, in the experiment, in the video you will come to know, when we do that, first keep 9 volts. Okay, this is 120 ohm, here is an emitter. Okay, Zener diode. First keep the pot in the minimum position. Okay, keep the pot in the minimum position, then vary the then check the emitter value, then little bit vary the uh, pot, check the current value, again vary the pot, see the current value. When we see like that, this current value is varying. Okay, then finally after many turns, okay, it comes to the maximum, this pot comes to the maximum position. Now actually we should see in which range this current was almost constant. I don't get exactly constant, okay, but almost constant. So whichever range I get almost constant, I should think that, okay, those are the load regulated loads. Okay, those are the regulated loads. Okay, don't think that from the minimum position of the pot to the maximum position of the pot, I will be getting a regulated voltage or regulated current. No. Okay, I may not get. I may get or I may not get. I don't know. I am varying in all possible values. For all possible values, I am varying. I kept it at minimum. Okay, I came something. Okay, then again second value, I was little bit incremented. Third value, okay, it is almost constant. Fourth value, constant. Fifth value, again it decremented. Okay, sixth decremented. Seventh decremented. So I should take second, third, fourth. That's it. Because those were the values of I where it was constant. So I can say that to that range, my impedance can be varied. So that was about the load regulation. See, now this is the expected graph. Okay, so this is the line regulation and here is the V naught, V in versus V naught. You can see it's almost constant. Okay, this is the load regulation part. Okay, V I versus V. See here, there is a very small dip. Otherwise, it is constant. And the load regulation is calculated, okay, using this formula. Percentage of load regulation is equal to V no load minus V full load by V full load. Okay, what do you mean by no load? Take these two, remove these two, and connect this minus to here directly. One value. Okay, remove 47 and 1K pot. Connect this I directly here. Okay, for 9 volt, one value you will be getting, that is V no load. Full load is this only. So you will be getting the load regulation. Okay, this regulation should be minimum 4%, 3%. Okay, as you get lesser, your device is performing better. So this was about the Zener diode and its application as a application for load and line regulation. Okay, so third experiment is over. Now I have posted the manual. I have posted the video done. Two videos are there. One video is for the forward and reverse bias, and the next video is for the line and load regulations. Okay, go through it properly again and again. You can see the video. That video here, actually, what I have told, I think if you were attentive, now it is sufficient. Again, you need not go through. Next you have to go through is those videos which I have posted. There again have given the explanation and I have demonstrated how actually value varies and in which range value remains constant and so on. Okay, so that you go through, and again if you have any doubt, you can come back here to this video and you can clarify. Now, any doubt? Any doubt is there? I don't have the name list, that's the problem. Yeah, here many are there, right? I can ask them here only. Okay, ready to unmute yourself. Ashna Kotian. Ashna, unmute yourself. Ashna.
Yes, ma'am.
Okay, okay. Ashna, you were listening, right?
Yes, ma'am.
Okay. Can you tell me in your words? I don't want the complete definition. What do you mean by uh, line regulation?
Line regulation, it is a regulation where load resistance is fixed and the input voltage is changing and
Okay.
output
Now,
voltage remains same as output
uh,
voltage remains same as long
output
as the input voltage is
maintained what?
maintained within the regulation range.
Within the regulation range.
Regulation range.
Yeah, 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 yeah. Correct. That's correct. Now,
Thank
Brian Matthew. Brian Matthew.
Yes, ma'am.
Okay, okay. Now, is always a uh, line regulated voltage is 6 to 12 volt?
No, there's a range of the voltage from 0 to 12. So,
It's always 0 to 12. I said 6 to 12, no? What is it
yeah,
then?
yeah, sorry, 6 to 12. Yeah.
It is always 6 to 12. You mean to say?
I think it depends.
Depends what? Depends on
The
what?
the input voltage.
No, input voltage only I'm talking about. Input voltage only I'm talking about. Okay, is it always 6 to 12 volt? If yes, why? If not, why? Hmm. Yeah, Brian?
Uh,
No idea.
no idea, ma'am.
Okay. Manvita? Manvita? Unmute? Yeah, fine.
Yes, ma'am.
Okay. Now, why that regulation should be there? 6 to 12 volt. Is it always 6 to 12 volt or how is it?
Uh, I'm not sure about that. A percentage of load regulation.
Huh? No, 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 no. Don't get confused. Percentage of load regulation is given to measure, okay, how much it is regulated. That's it. Percentage of load regulation. Now I'm talking about the line regulation. There is a difference between load regulation and line regulation. I hope you are clear about that, right, Manvita?
Ah, yes, ma'am.
So I am talking about now line regulation. Okay.
Um,
Anybody you can unmute and answer me. Anybody. Is it always 6 to 12 volt? That's a simple question I'm asking. Or else I only should call the name. Whom is it? Rahul Shettigar. Rahul Shettigar. He's there or he has left? He hasn't left. Yes. Why can't you answer? Rahul, unmute yourself. Can't turn on mic. Why? What is the problem? Every day we get the same. Okay, Sannidhi. Sannidhi. Where is Sannidhi now? What happened? Again, you can't turn on your mic. Why? I think you all have a good quality of mobile. Most of you have. I know that. Don't deny now. Why don't the mic turn on when I call you all? Huh? Something looks very fishy. Karthik?
Yes, ma'am.
Okay, fine. Uh,
Mm.
Tell me, Karthik.
It varies, ma'am, because
Uh,
it depends on the concentration of doping concentration of Zener diode.
exactly, exactly. And also, it depends on how do I design my Zener diode.
Zener diode.
Yes. Okay. Now I have shown you. We have designed it for 4.7 volt. Okay. So my input can be 6 to 12 volt. And in the beginning itself, I said Zener diode we can design it for 1 volt to 200 volt. Okay. So in that case, I can't say that okay my input is only 6 to 12 volt. Okay, then that is not called as regulation. So depending on my design of the Zener diode, my input voltage also will vary. Correct. Fine. Next, what is the difference between load regulation and line regulation? Nivedita P. Nivedita P. Load regulation and line regulation. Hmm. Where is she? Nivedita. She'll text now. Yes, ma'am. Mic issue. Nivedita is not there. Satvik, come in.
Yes, ma'am.
Okay. Can you tell the difference between
Uh,
load regulation and line regulation?
in line regulation, the input is varied, and in
Uh,
load regulation, resistance load is varied.
uh, okay, that's correct. Now tell me, why did we do that experiment? Load and line regulation. Why did we do? Satvik only. Satvik only.
Yes,
Yeah, why did we do that experiment? Huh. See, some aim should be there, no, to do the
ma'am.
experiment. Huh.
Yeah.
Why did we do? Any idea?
Finding the regulating voltage.
To find the regulating voltage. Fine. Then one more thing is one mm, one more way is
Uh,
huh.
then characteristics of Zener diode.
No. That was the first part. Characteristics was the first part. Okay.
Yes.
Huh. Is anybody? Anybody? Ishika? Ishika, unmute. Ishika. Nivedita has left the meeting. She is also not there. Ishika. Where these people are? Just logged in and they have left. Is it so? Danya?
Yes, ma'am.
Okay. This thing, okay, you are there now. Why the this thing load regulation is done? He said why the uh, line regulation is done. That Satvik said why the load regulation is done. That experiment was conducted.
To vary the load resistance and to see for how much variation will get a constant output, that's regulated output.
Regulated output, because in that range I can work, right?
Yes.
If I know that range, then I can like I can design in such a way that the load, okay, if at all varies within that range, then I can manage. Correct, no? Yeah. Now actually I will Okay, keep 2 minutes or 1 minute for anybody. If they have any doubt regarding the experiment, you can ask me. Otherwise, yeah, it's done. Anybody, you can unmute and ask. No? Nivedita is not able to join the class again due to network issue. It's okay. Okay, okay. Fine. I think no one has the doubt. Then we'll wind up here only. Okay, go through the video which I've already posted, and this also I will be posting. If anyone has missed, or if you want to again go through, you can do that. Okay, thank you.